Homework 7, number 7. So in this problem, you're told that let A be any vector of integers. For part A, create a vector B whose all components are the even entries of the vector A. And part B, repeat part A, where now B consists of all the odd entries of the vector A. So let's navigate to MATLAB and see how we're going to do it. So you want to find the even and odd numbers of an integer, right? So what defines if a number is even or odd is if it's divisible by 2, right? And so if it's an even integer and you divide it by 2, you're going to get a fixed integer without any decimal places or without any remainders from the fraction. If it's an odd number and you divide by 2, you're going to get some decimal places or you're going to get a remainder. So if I write 3 divided by 2, I get 1.5, 4 divided by 2, just 2, etc. So I want to check basically if any number when divided by 2 will give me a remainder. And in order to do this, there's a function called REM. So if I write REM, for example, 3 divided by 2, or let's see, let's write help REM to find how this function works. So rem is a function which gives you the remainder after the division. So rem xy returns x minus fix of xy. So if I write basically rem 3, 2, it's going to give me 1. So this is the remainder 1. 3 divided by 2 is equal to 1, remainder 1, right? Rem 5, 2 should also get 1. Rem 5, 3. So if I divide 5 by 3, I'm going to get 1 and then 2 left over, right? Because 5 is equal to 1 whole 3 plus 2 numbers on the side. So I'm going to abuse this sort of function to solve my problem. So let's go back to the problem and recall it. So if you're given a vector A of any integers, create a vector B whose all components are even entries of the vector A. And then repeat part A, where now B consists of all the odd entries of the vector A. This is not an easy problem. This is slightly tricky. But let's try and approach it. So let's go back to number 5, and I'm just gonna use the same vector A I used in that problem. Okay, so let's say you're given a vector A which consists of these elements. So now I want to create a vector B which is equal to B is greater than rem of A. So I want to create a vector B. Let's see if this works. Rem of A, comma, 2 equal 0. This doesn't work, right? So if I say A, it's gonna give me this. So what I tried here is I tried to use this function or this inequality, solve the problem, but it's not the best way to do it. So let's open a new script and try and approach it that way. So again, I'm just using A. It could be any set of numbers. And logically, I'm just gonna run a for loop and loop through every element and then save the even numbers in an array B. So let's call this part A. And again, let me clear my memory. Clear CLC at the start of this code. And here, basically, I'm running a for loop for I equals 1 to length of A. So again, I'm just running a loop over the length of A. And B of I, or in this case, instead of using B of I, I'm going to create a second counter, K, which I'm going to use to only save the even numbers, because if I only use I, I'm going to end up with some zeros or some empty blank spaces in B, because not all the numbers are even. So let's logically try and let's try to do it logically first of all. If remainder of a sub I comma 2 is equal to 0, so if the remainder when dividing an element by 2 is equal to 0, basically checking if the number is even. If the number is even, then I'm gonna say b of k. So I'm gonna create a counter k outside the loop. K equals 0. B of k is equal to a of I, right? And let's call this b even, and else b odd of, let me create a second counter j. I'm gonna initialize it. Let's call this 1, and then this will be 1 as well, because my first element has to be 1. And then I'm gonna say k equals k plus 1 here, and then b odd of j is equal to a I, and j equals j plus 1. Okay, then I'm gonna end, and this should do it for you. So let's go through this loop and see if the logic makes sense. So what I'm doing here is, you're given a list of numbers a, whatever they may be, and in this for loop, I'm running a loop over all the elements of a, and I'm checking every element one by one if it is even or not. So for I equals 1 to length of a, so I'm running a loop over the length of a. I'm using an if statement to check if the remainder of the element a when divided by 2 is equal to 0. So if the remainder is equal to 0, there is no remainder, then the number is even. So for example, 4 divided by 2 will give me 2 without any remainder, so it's an even number. So if this element is even, I'm going to save this element in a vector. I'm calling it b underscore even. It's equal to ai. And in this vector, I'm using another counter, right? So if I use I as the counter here, I'm going to end up with a vector b the same length as the vector a, but with some empty elements, which doesn't make sense. So I want to compress all the numbers into the vector, right? So I'm just creating two counters. So I'm creating a counter for this array b even. I'm calling it k. So b even of k is equal to ai, and then k equals k plus 1. So I'm incrementing k. And then if the number is not even, this means it is odd. So b. So if it's not even, else it's odd. So I'm gonna store it in the second array, which has the odd numbers. B underscore odd of j is equal to a of I, and then I'm using a separate counter for this array, calling it j, and j equals j plus 1 as well. So after I'm done with this loop, I'm just gonna show my even and odd arrays, b even and b odd. And let's run this. So I'm gonna run it. It will ask you to save it. Again, save it in a location which is easy for you to find. Homework 7 here, I'm gonna call it HW7 number 7. Okay, add to path, whatever, just add it to the path. And let's run it. So if you run the script here in the command window below, you see that I have two arrays. B even has all the even numbers, 4, minus 2, 6, 16, minus 1000, and B odd has all the odd numbers, 3, 1, 1, 5, 9, 5, 15, etc. So this script will do both of them for you, right? And basically this part here does part A. So let me remove this comment. And this part right here will do part B for you, right? So this is part B. Let's run it again. And yeah, so you're able to extract your even and your odd numbers from a vector. And we can test it with a simpler set of numbers. So if I go back to MATLAB and I change A to just 1, 2, 3, 4, 5, 6, 7. So A is 1 to 15. And I run this, you can see that the even numbers are in this array and the odd numbers are in this array. So this was not an easy problem. It's actually one of the more difficult problems, but try to replicate it, try to understand the logic of what's being done here, and come back to me if you need any clarification.